Bonjour, mesdames et messieurs. Good morning, ladies and gentlemen. Buenos dias, señoras y señores. And welcome to ICAO's 13th Air Navigation Conference, SkyTalks. This is day 5, session number 21, and I'm assuming all of you have been here since the beginning to watch these informative sessions. We've had some great speakers, experts in their fields, respective fields, and we welcome you. For those who have missed, may have missed one or two of them, to go back into YouTube, type ICAO SkyTalks, and we have the full list of topics for you. Now, my name is Sung-Hoon Kim, and I'll be your host for this event. I want you to think back and possibly go back and think about what points in time were the most important for you. Well, some people may mention like their first cell phone or the invention of the telephone or light, or go as far back as Adam and Eve eating the fruit of knowledge of good and evil. But for me, it was actually when I was much younger. I still remember my first experience with ice cream, and I could see how it transformed my life. In the aviation industry, we have something that every year, which grows in leaps and bounds, and I'm talking about the RPAS, or remotely piloted aircraft systems. To tell you about this topic in more detail, please welcome Mr. Frédéric Malaud, ICAO's Technical Officer in the Air Navigation Bureau.
Thank you very much for this introduction, and good morning, ladies and gentlemen, and welcome to what I hope will be an interesting, informative, and perhaps thought-provoking session. So, my name is Frédéric Malaud. I work as a technical officer in the remotely piloted aircraft systems section in the Air Navigation Bureau at ICAO. And just to set the scene, a word of introduction. As was rightly said, unmanned aircraft represent and offer a vast range of capabilities and sophistication. They do constitute a growing industry with considerable operational opportunities and also economic potential. However, since their associated technologies and designs and operating concepts are evolving very rapidly, states and regulators generally are being challenged with their safe and efficient integration within the aviation system. And we have to remember here that our priority in ICAO and in aviation, since the beginning of aviation, is safety. We need to ensure that whatever happens is done in a safe way. That is an absolute priority. So as you can see here, the presentation today will basically give a very broad overview on the process leading from segregation, first, of unmanned aircraft to accommodation and to hopefully integration of unmanned aviation within the aviation system. Accommodation describes the condition when unmanned aircraft can operate within the airspace using some level of adaptation or support that compensates for their inability to comply with operational constructs. What we're aiming for is integration, eventually, and if all the conditions are satisfied. That refers to a future where unmanned aircraft may be expected to enter the airspace system routinely without requiring special procedures from air traffic control. But of course, such integration will require advances in technology, as well as the development and implementation of standard procedures, as well as guidance material. That is where ICAO comes in. So the presentation today will go through the opportunities, operational and economic, presented by unmanned aviation, the challenges associated to these operations, and how these are being addressed by states at the international level through the work of ICAO. Look at these images, and I'm sure these will resonate when you just heard our MC talk about the considerable advances in technology. What we're witnessing today is absolutely fascinating. I'm sure that all of you receive on a daily basis news and information regarding new technologies and developments involving unmanned aircraft. And unmanned aircraft are being and will be used eventually in a variety of applications. The list is long as it keeps growing every day. Just to give you a few examples: wildfire mapping, agricultural monitoring, disaster management, thermal infrared power line surveys, law enforcement, telecommunication, weather monitoring, aerial imaging and mapping, television news coverage, sporting events, movie making, environmental monitoring, not to mention oil and gas exploration, as well, of course, as package delivery and freight transport. Now let's pause for a minute and reflect on the words of our MC and look at what's happening, which is truly fascinating. I think the transformative power of these industries precisely lies in apart from the transport, the ability to transport cargo and passengers eventually, the ability to see the Earth from above. When you think about it in the grand scheme of things, from the beginning of mankind, and human activities have involved the need to get information from above about what's going on the surface. For centuries, for activities such as agriculture or for infrastructure planning, building roads, building bridges, and so on and so forth, humans have had a need to see what is happening and to collect information from above in order to plan these activities. Now, in the late 19th century, aviation appeared, and during the 20th century, these activities, which used to take days or perhaps even weeks to complete, now suddenly took a few hours through the use of airplanes and helicopters. Now, with these new technologies, the business case is extremely strong. What used to take now hours can suddenly take even less time, including sometimes minutes. An example that comes to mind is in the mining industry. When you have open sky quarries, you can now, using a so-called drone, an unmanned aircraft, get a 3D picture of such quarries, a three-dimension picture, for a fraction of the cost, and also in a very much shorter time. So the opportunities, and that is just one example, but the considerable opportunities that exist are just mind-blowing. The socioeconomic benefits deriving from these activities are also considerable. According to some industry studies, the European unmanned aircraft market is expected to be worth over 10 billion euro annually in 2035 and over 15 billion euro annually in 2050. In the US, other studies have shown that the integration of unmanned aircraft into the national airspace is forecast to support more than around $14 billion in economic activity in the first 3 years of integration, as well as the creation of over 100,000 jobs by 2025. That highlights the considerable potential of these technologies. Now, a number of examples what is happening also right now, and I'm sure all of you have seen these examples. A number of small electric-powered aircraft that take off and land vertically may enable rapid and reliable transportation between suburbs and cities and within cities. The use of these aircraft can enable significant savings in commute time and therefore contribute to urban mobility. From an economic perspective, these urban-powered networks are expected to have significant cost advantages over traditional ground transportation and air transportation, which usually require heavy infrastructure such as roads, rail, bridges, tunnels of airports. With these new technologies, tops of parking garages, existing airports, as well as heliports, and even unused land surrounding highway interchanges could form the basis of an extensive distributed networks of dedicated operational sites. Also to mention the lower costs and increased flexibility provided by these innovative approaches may substantiate strong business cases for cities and states around the world. Other examples here you've certainly heard of, ongoing flying taxi projects which aim at the development and introduction of highly automated unmanned aircraft systems that would be available for use as taxis by the general public. These are expected to carry passengers and will of course require a blend of certification requirements from both manned and unmanned aircraft categories. Wish to point out that while certification standards are under development for remotely piloted aircraft, RPA, they do not allow for people being on board at this time. Advances are being made in this field in different regions that you've certainly heard of. Remember that the primary objective is always safety in aviation. Now, in order to attain safety, and aviation has a extremely good track record at safety, we need to look at what we're talking about when addressing unmanned aircraft. What is meant by unmanned aircraft? Well, and I'm sure you've witnessed the use in the general public or in the media of a number of terms, perhaps sometimes in an not consistent way, interchangeable way, such as UAVs, UAS, drones, RPA, RPAS, and so on and so forth. These terms are used in a way that is not necessarily consistent, and what we're trying to do is to introduce some consistency. So first, a few basic definitions. An unmanned aircraft is indeed an aircraft. An aircraft is defined as a machine that can derive support in the atmosphere from the reactions of the air, other than the reactions of the air against the Earth's surface. Which means that any machine that matches that definition is an aircraft. And that is true whether it is manned or unmanned, whether you are talking about small drones for delivery, recreational purposes, or inspections, or used as a flying taxi. It applies whether these aircraft are used with a pilot or without a pilot, or using high levels of automation. It applies whether passengers are carried or no passengers are carried. And these development and these aircraft, of course, involve both traditional and innovative aviation technologies. Now, going further into the definitions and the clarification of terms, I find it useful to make the distinction between unmanned aircraft versus RPA, because these terms are often used interchangeably, as I said. You have the broader group of unmanned aircraft. And there are four different categories in unmanned aircraft. The first one is free balloons, usually used for meteorological purposes. Second, model aircraft that are essentially used for recreational purposes. Third is what is called RPA, remotely piloted aircraft. And these are highly complex aircraft that are piloted from remote locations by licensed aviation professionals. A remotely piloted aircraft system, an RPAS, is a system, which means that the system in itself is composed of different things. First, an RPA, which is the aircraft, the flying machine, remotely piloted aircraft. A remote pilot station, RPS, which can be either on the ground or at sea or in another aircraft, but remotely from the aircraft. You need also a C2 link, what is called a C2 link, which is a data link between the RPA and the RPS for control and management of the flight. And also other components as specified in the type design. The fourth category, which is commonly referred to as drones, is the one that is of a much smaller size and weight, and we will go into some little detail about that shortly. This is another way to look at the general category. You can see on this graph here the whole spectrum of unmanned aircraft and its four subsets. Important to notice that in the upper quadrant, you have this is the quadrant of RPA, remotely piloted aircraft. There is a further subset of RPA, which is in the inner upper quadrant, so to speak, which is the subset of RPA that is expected to be accommodated and ultimately integrated into the airspace for international instrument flight rules, IFR flight rules operations, and that is the subset that will require full regulatory certification, and which is the one that is being addressed through the RPAS panel at ICAO. As well as the other categories described here, the small unmanned aircraft, commonly referred to as drones, generally less than 25 kilograms, as well as unmanned free balloons and model aircraft. Now, we have just clarified the difference between remotely piloted aircraft, RPA on the one hand, and other unmanned aircraft on the other hand. In terms of work that is being done at ICAO to address the regulatory framework for these operations, first, I just mentioned there is the Remotely Piloted Aircraft Systems Panel, the RPAS Panel, which addresses the full regulatory approach, the fully certificated aircraft on the one hand, and the other unmanned aircraft on the other hand. So the RPAS panel serves as the focal point and coordinator, essentially, at ICAO for RPAS-related work, and its aim is to ensure interoperability and harmonization. Very important to note here and to remember that the panel's work is focused on international IFR operations. The panel also develops guidance material to support and guide the regulatory process. Now, regarding the other stream of activity, the ICAO Assembly in 2016 asked ICAO to take a leadership role in the development of standards and guidance for the harmonization of regulations on other unmanned aircraft that remain outside of the scope of international IFR operations. In order to facilitate this expansion of ICAO's work program, an innovative and flexible approach was recognized as being necessary. Just wish to mention that in the framework of this approach, ICAO has developed an online toolkit, which is available online. If you are interested, I'm sure you are interested in additional information on ICAO's activities in the unmanned aviation field, a good source of information is indicated at the link that is on this slide here. By accessing this link, you can access not only the toolkit, but a bunch of other important information. We have developed what is called the Unmanned Aviation Bulletin, which reports on operational and regulatory developments in the unmanned aviation industry, as well as connected activities. The idea through that tool is to promote the exchange of information amongst states, countries, and this is also disseminated electronically and, as I said, available on the Unmanned Aviation portal at ICAO. Now, moving to the achievements and the activities of the RPAS panel, there is first also a good source of information to set the scene for those of you who are not familiar with the actual development of specific standards and procedures and guidance of ICAO through the panel. A good place to start is to look at the manual on remotely piloted aircraft systems, what is called DOC 10019. This covers a pretty broad range of different areas that need to be understood to grasp the complexity of this industry and the regulatory process. Now, amongst one example, the absence of a pilot on board brings the challenge to ensuring the ability of the pilot to see and avoid. Many of you are experienced aviators, I'm sure, and I'm sure you remember when you started flying, one of the first things that you are taught during the first days is to see and avoid. When you are in an aircraft, you need to look around for traffic and avoid the traffic. Now, when you think about it, there is no pilot on board an RPA. So that generates significant concerns. Safety is paramount, so you need to avoid potential collisions, as well also as obstacles and potentially severe weather conditions. Technical solutions have been developed to control the aircraft through data link from remote location, which is what I refer to as the C2 link. So the guidance on many of these different aspects is contained in the manual. Also, one notable characteristic of unmanned aviation's regulatory framework dealing with RPAs is that the automatic recognition of pilot licenses and certificates, which is provided for under Article 33 of the Chicago Convention of 1944, is that the automatic recognition does not extend to remote pilots. So to address this gap, ICAO has recently developed and adopted amendments to what is called Annex 1 to the Chicago Convention, which develops a framework for remote pilot licensing. Just a few examples of work underway in many different disciplines. This would take many hours to detail, so I'm going to be short. Just for you to get the global picture, RPA operating internationally must satisfy requirements under the Chicago Convention. As such, they must have a special authorization from the state in which airspace they want to conduct operations. There's also a need for an operator certificate and a certificate of airworthiness. Now, ICAO is developing a new Annex 6 Part 4 called International Operations, Remotely Piloted Aircraft Systems. That is one example. For airworthiness, what is airworthiness? Airworthiness is addressed by Annex 8 to the Chicago Convention. It's basically a determination of an aircraft's suitability for safe flight. In the case of RPA, airworthiness takes into consideration all components of the system, such as the RPA, the RPS, the C2 link, and other components. In addition, RPA must comply with communications, navigations, and surveillance requirements in order to be adequately integrated into the airspace. So key enablers for RPA integration also include what is called detect and avoid capabilities. In order to compensate for the absence of a pilot on board, you need to design capabilities in order for aircraft to remain well clear from each other's. Mitigation of cybersecurity threats is also a very important aspect, which is addressed at ICAO. One challenge is insufficient data, and that applies to all these aspects. There is limited feedback because it's such a nascent and highly developing industry that the data, the return of experience from the industry is still in the process of being collected. That is a challenge for regulators because there is no such thing as a huge repository of operational and regulatory experience that is used and that exists for for regular manned aviation. Also, another aspect to be mentioned very briefly is the management of frequency spectrum. Frequency spectrum is a rare, scarce natural resource, and the work is being done under the auspices of the International Telecommunications Union in that respect. Other annexes impacted by unmanned aviation, Annex 17 on security, Annex 18 to be amended to address RPA employed to carry dangerous goods, as well as Annex 19 on safety management, which is being extended to certified categories of RPAS operations. In a nutshell, unmanned aviation, in order to be safely integrated into the aviation system, requires the adaptation of all the annexes to the Chicago Convention. The task is considerable, and it is being addressed at the ICAO level. Now, a quick word on other unmanned aircraft. We just talked about the certificated end of unmanned aircraft, those that are to conduct international IFR operations. Just to talk about briefly a range of emerging activities taking place at a very low altitude, essentially in urban and suburban environments. The increasing numbers of these aircraft, both manned and unmanned, that are and will be operating in metropolitan areas require new approaches to air traffic management. The UAS traffic management concept can be defined as a system that provides traffic management through the integration of humans, information, technology, and facilities supported by air and ground and/or space-based communications, navigation, and surveillance. Any framework for what is called the UTM will need to include several key components. First of which, registration system. Second, communication systems for the control of the unmanned aircraft. Third aspect, geofencing-like systems, for instance, restricted areas or controlled areas where unmanned aircraft should not enter for safety purposes. Now, just one major difference of the UTM with existing air traffic management is that instead of the traditional voice data exchange between pilot and air traffic controllers, it is expected that the communication and coordination in the UTM will take place through a distributed networks of highly automated systems. It should also be noted that the airspace between the surface and 1,000 feet above ground level is already the operational environment of other users, such as low-flying helicopters, which also will need to be integrated into the UTM system. So identifying the infrastructure requirements for this system will require active cooperation of states, stakeholders, and potentially through innovative or mechanisms associating the private and public sectors. Just now wrapping up on this presentation, time is running, and in closing, I just would like to emphasize a few things here. ICAO will continue to work for the integration of remotely piloted aircraft into the airspace, as well as on the harmonization and implementation of regulations on UAS. We are and we will keep working on solutions for the UTM, possibly through mechanisms associating, of course, regulators as well as the industry. What is key is to keep collecting and providing technical data on RPAS operations. It's also very important that states share information on what is happening at very low altitude, particularly on the operations taking place there and on the way these operations are regulated or at least approached. And very important as well, that's something we take seriously, ICAO will keep continuing its activities to share knowledge, raise awareness, and conduct educational activities, and therefore fulfilling its role as the global forum and facilitators for unmanned aviation. Ladies and gentlemen, this brings me to the end of my presentation. Thank you very much for your attention, and I'd be happy to take a couple questions if we have time. Thank you so much.